sorry, I'm going to stand over here. My clicker died. I don't know why I have two of them, but that's what happens when you grab one my touchpad and also dies. The usual problem is everything goes wrong. Stuff. You got one at work? Okay. No. All right, we'll get by. Okay, so this talk comes from a keynote that I did for the Agile Meets Architecture Conference. It was a really interesting conference. It was conceived by a wonderful gentleman, like Seven Tuckout, who's the CEO. I mean, I'm few that unfortunately lost, but amazing contributor to the software industry. We had this idea that it would be good if we could bring architects and agilists together, because for some years, no need, no think in architecture was the badge of honor of the XD Agile community. Don't need design either. You just need to trust the code. The good news was the conference was very successful, but I think much more so for the architects than the agilists. And one of the problems we have in the industry is bringing groups of people together, which is why things like meetups are so important. To bring people who come from different perspectives together to share their opinions, particularly the things where they're different. Because we learn from the differences. We learn from what we do wrong. You can always have someone pat you on the back. Always, I mean, people work for me, particularly OPI, they think it's a bit weird working here. Nobody gets really excited. We expect things to work. So we really get excited when we get the defect or the customer's complaining because now we have something to do. But shipping the code on time, basically we sold a process called just-in-time software for some 20 years. It's guaranteed that you didn't get the software on time. Okay? So that wasn't, and for some reason, Agile people seem to think that's a difficult problem. No, I know many companies have done it. Adapt that stuff as well, which we do. It is possible. So we have this other problem between product and the Agile community as well. That gap that's really in it. That's a really serious problem. A very good friend of mine who probably knows this Agile. In the Agile community, at least, it's still not. Jeff and I talked many times about trying that it's very hard. People don't even want to get together. So I think that's a sign of an unhealthy culture when people don't want to get together and discuss or share this kind of stuff. So I enjoy this conference and it's a great time on here. In fact, the topic I talked about yesterday was also. So, as I said in the beginning, we have nice Agile, where basically you don't need any design, you don't need any architecture, and pretty soon you have all the Agile developers whining for technical debt. Technical debt comes from not incremental improvement. Refactoring is one of those things that is just a lie in most organizations because you're not refactoring. It's not an equivalent to preserving transformation. You're rewriting it, but you're lying to your management because you want to do the project and tell them, look, we've got this really wonderful thing called refactoring. That's absolutely nothing to do. You can rip the program apart. You're going to rewrite it. You're going to run the budget a long time and have a big mess. And that's what happens to a lot of big Agile transitions. They disguise them as a set of refactoring. There's not refactoring at all. One of the character tests of a legacy system is it doesn't have that. So, and of course, there's this other lie about refactoring tools. Refactoring tools are toys. Little movement methods are enough. But if you want to refactor a large code base, you need a very sophisticated tool, which today doesn't exist. So you can plan the refactoring in Teams. I've seen it done with big monitors, special tools. But so just a word before you tell your boss, we're just going to refactor it. Please don't. So today we're really going to talk about a problem. All things start with best intent. So we start with some good diagram discussion, sketches, and then eventually, you know, the pressure comes. Just when we don't need them, we double or triple the number of devs we have working on the project. How'd you like to work at Uber when they put 3,000 devs in the company in one year? They can ship a lot of useless features, and you get to see them in the product. But they measure the feature up. So in the end, you're stuck with this code. And no matter what Luke says, that's not a great idea. You get code, once you have a lot of it, kills you. My one-liner is K-lock kill. You ship more code in every release, you'll have to fix more code. So the measure for us of this is a good release is there's less code in the release than the previous one. So a really good book describes it very nicely. Wonderful guy, George Fairbanks, wrote it, but just enough architecture. Just enough is actually a great phrase for almost anything. Just enough DD would probably be this year. We've had way too much ArcDev. But the problem is that basically you have these architectures which are models, but the model is never the code. And in case you came believing that I was going to show you how you can keep these perfectly aligned, I'm going to show you how you can try and keep these aligned, because a lot of these things in the end require human glue and disciplined practice. So everyone knows that architecture typically has a lot of models. And models in engineering are really good. To be an electrical engineer, so I always thought modeling was a good idea until I got the software. I would say it, but literally some of my best friends invented do it now, and I really feel bad for people who have done it. But the important thing that people don't realize in this whole conference called models every year is this whole notion. It's great to have model-driven code. The problem is you can't assume that there's a reality between them. They're not equivalent. A model is useful because it's partial, because it lets you look at some aspect of a system, and that's why we can model it. And if we do that, we can do all of these. We can explore alternatives, we can simulate, we can validate. And for some things, for instance, for the Mars lander, I don't know if you've heard anything Luke has taught, but this is a very complicated thing when they go hypersonic parachute. In 7 minutes, this thing lands and the planet turns itself around, it turns on jets, has to be high enough so the jets don't tear up the guts. Incredible thing. One of the great things at the hour of the audience is that Anita, how'd you test it? And it's that anxiously waiting. This is a one-time deal. You can't test it. What we do is we do models and simulations, everything, until we think we've got it right, and then we shoot it off. We don't know until it's right. So modeling is very, very important, but it's not enough. So one of the great ideas that people have now is that, and it's been around for a while, if you haven't still, this is really my favorite one, Coding the Crime Team. If you've not seen that, it's a wonderful book. Glamorous Toolkit is a neat one because it essentially builds micro tools to actually live in the architecture. The people from Learn have a very nice toolkit And they work with companies like huge code bases and essentially build customized tools to allow people to explore the code, visualize all the things that are happening. But it's a lot of engineering work to do. It's a multi-year commitment. The problem with these tools, of course, is that you get one of them. Famous microservice. This is very useful. Adrian talks about a good friend used to be at Netflix and Amazon. So that every microservice sucks almost every other microservice. Thank you for that. The other thing is they often show you things like Sonar, which is here, around here. They actually show you the hotspots in the code, but it's like we got an architecture at Saturn, the architecture conference with a founder of Sonar. We were just sitting talking. He said, so what do you think it would take for more people to actually leverage Sonar? Can I just draw on the bottom? Can I do a button? Because the problem is it shows you all, and you can cut things and these move apart, but these tools just are not up to snuff. And often they just show you what you already know. Right? The consultants come in, they run the tools, they show you this big knot. You said, yeah, that's why you were brought in, but now what is going to help us with this? So it's important to run these tools all the time because you want to picture your architecture as it's evolving and at least picture your code base because that will show you how you're drifting from your architecture. I'm trying to do that. So what I want to talk about is really the point of today is what are some things that we can do to try and close this gap? We're never going to, the architecture is never going to be going first, except at the beginning. And it's always going to be somehow out of date. But what can we do, but particularly if we're working in something where we know we're going to be growing in those areas? And the key things here, I'll go through each of these. I won't bore them with them. So it doesn't start, has to start and end with people. Here. The things we found most important, I just picked them out here. First one is that you need a topology. That's a great word, team topology. This is something that many of us have been doing for a long time, and so the team topology and we built in clips and so on was a key part. It's also a key part of what we're on. You probably know already about Eclipse, but I can show you how it reflects the people who were working on it. Where Eric Gammon was, what the songs were that Eric Gammon played the code base, and why he learned from that. So when he built Microsoft Visual Studio Code, he finally listened and made it all scriptable instead of everything flooded. These are just lessons, just code, and people make decisions and then they learn. Something that's very important we found is a lot of companies don't have two ladders, called a technical ladder. In the US and typically in Europe, they call it principal engineers. In the United States and Canada, we call them distinguished engineers. These are kind of people who can be a playing coach. My friend, although I completely disagree with him, Levi Jakobson, thinks that you give people a process and some models, and it doesn't really matter what tools you use or anything like that. 10% of the effort for building software. He's entitled to say that because he doesn't actually build any software. But the reality is that this key leadership is very important. And so typically, the senior engineer is two kinds. One has a whole product team underneath them. You could think of them in the Toyota sense as the chief product officer or the chief engineer. Others have small teams or maybe two or three people, they float around. They carry the essence of the architecture. And this is an old principle from factories that basically the best management is the management by walking the ground. So you can say, by the way, do you know that you're doing exactly the same thing that the people over here are doing? When we were building virtual machines for Smalltalk and Java for IBM, IBM had 40 GUI builders at one point, and 7 VMs, all actively competing with each other inside the company where you couldn't get enough resources with the right skills. Virtual machine skills are very rare relative to others. So having these leading playing coaches share the things, they can share best practices. And by the way, if your company says it's doing best practices and it's the same as every other company's best practices, they're the same practices, they're not the best practices. So if your process is changing, if your process is different than what other people are using, then your process is by definition non-competitive. Because your processes and your tooling and your people are what make you competitive. So you need a bit of innovation in your organization to change those things. So I put this up here because so many people today seem to think that it has to build everything. Standards and COTS are very important. Avoid open frameworks. Frameworks are something that injects dependencies into your program. You had a nice piece of software, had minimum dependencies, and you went and got something out of GitHub, and it basically as a framework, and you got all these dependencies you didn't count on. But you have to know to use a framework how to live inside the framework. So you right away violate encapsulation and get tons of defense. We are very, very strict about bringing anybody else's code into our organization. Because most of the difficult bugs we find are not due to our own code. They're due to dependencies on other people's code, including the hardware. Some of the most difficult bugs of building virtual machines for the fact that the microcode doesn't work on many computers. And when your garbage collector fails for some reason, you actually have to get the circuit schematics out of the silicon. That's not working. Same problem building networks. We built a very conservatively designed network architecture. Instead of making interrupt driven and totally reactive, we built it simple. Let's just get it working and make it a simple polling. Polling those long term are a bad idea. Short term, you get something else. Only to find out the checksum never came through. How could that be? Well, guess what? It takes an extra couple of clocks to actually do the checksum calculation. And because we were polling quickly, we actually never checked on it. So when you can't trust the hardware, and you've got a bunch of software on top of it, or on top of that, you just get into very, very subtle and difficult topics. We spent 2 years doing this. We spent basically you wrote the virtual machine from that Smalltalk in under a year. It took us 4 months, and we built the UI using Bitlit. Apple didn't even know that it wasn't using the Apple toolkit. Built that in about 6 weeks. But we had an error, which we were sure was our reference question. Again, a bug in multi-language was told to know what that is. This is a multi-passage. It took us logic analysis, scope, and just a lot of good guessing. So even when you say, well, this has come from Apple, Apple does everything right. You get stuck with these problems. So you want to share the practices and technology. It's great that everybody in your own microservices team now, you can use your own programming language, your own framework. You know, use a different cloud vendor if you want. You can do all those things, but the cost of carry of that's very high. And if you don't rotate people from those teams, you will end up with really severe problems. You end up with tech silos that are much worse or harder to fix than business silos, which are very common. This system does the subsystem. You're back in the old subsystem. Cost of carry is something really, really important. Basically, if I use this new language, this new tool, this new framework, new things, a new practice, what am I going to pay for? It really lets you give things sober second thought. Because every time you introduce some kind of new thing in there, you introduce new unknowns and more issues, and typically maintenance costs. After all, the cloud's much cheaper, right? So just get those virtual machines and spin them up. Some people can't even turn them off. So rotation, things like basically, I think it's always important. The only things that really matter are predictability and quality. If the customer's not happy and you can't deliver on time, you're not a good customer, a good delivery organization. Try and keep the API simple. Some people at the API feel the range, right? But let's go to AWS Summit. Here's another 100 API services. Here's another 100 APIs. We'll just give them out and wait and hope for this program to come. And it's not only that, we've given you some videos, some toy apps we built. So now every core user group will be demonstrating and discovering how to use the API because they're fully documented. And not only that, we published them so they're sorted alphabetically, so they'll be easy for you to use. We design as an API. Most APIs just easy. So what I do is encourage people to say, look, what you really want for your read APIs is a select space. Not to be official select. SQL is very powerful, disgusting, but it works very well. Developers turn their nose up until you get used to it. That's so much too. Otherwise, you could say, I want these two fields out of, let me just get this out of SAP. Build another API. So, all this maintenance problem, all these APIs are inconsistent as hell. And if they're built by different teams, oh man, there's no way they use the same conventions, the standards, or anything. So you're just encouraging your architectures to diverge like crazy. It'll be very, very hard to do. I mentioned this. I also mentioned this. You always think and encourage people. I mean, I'm into this floor, basically asking you, why is it going to take so long? And why is it this much code? I say, always ask about the code because developers don't like talking about the code. I do say, how many functions do you think this is? They'll talk to you. Then I can say, what language programming? Oh, Python. Oh, C++. Okay, I understand the numbers are going to be different. But very important. KLOC's really do still, so you want to try and get it. So we monitor every release, the size of all the modules, and we used to have a thing on the wall. Basically, no one wanted to have their code of their module bigger than the dip. For sure, no one wanted to be the elephant of the room. We compute and sort these things. If you broke the build, you had to put it. There was a big red lobster on your build. And you did not want that lobster there 3 times. Because that lobster came 3 times. You probably want it to continue. You can't afford to take down the factory just because you wanted to try and cut some stuff a little bit without having it cut. And so you all know the continuing. So at the beginning of your project, there's something amazing about humans and distributed software. Sometimes you can go for weeks, just giving you a few little messages, putting things in a wiki and things around the world, build stuff, and it goes amazing. And sometimes they're working on something that seems so simple, and everything goes south. So people are upset with each other. There's raging. They got escalations because they have management layers that don't do anything except escalate. Somehow, you lose control of the community. So the thing that's really helped us as people, and if you know about great product people, they articulate a vision. In XP, it's called a metaphor. Um, I really just call it a really big story. So some of those, are pretty straightforward based on the clip. And the clips is really two stories. One you know about, the other one you don't. But the clip story was basically with everyone in the room. I would say what we need to do, basically IBM was late coming to the party. They actually acquired us to be able to compete in the Java space. And that clearly the enemy is Sun. And I won't tell you about all the dirty tricks that Sun did and so on. But Sun was not a very nice company. Scott was really the other. But IBM is a very loyal part. And so IBM will put 25 or 50 anything in the Sun to help that. So, but Sun in the end is always the idea was to get IBM to have to adopt it. And they actually, in fact, virally even graduate students with the Sun source code, except OTI also completely things. So we didn't have access to Sun source code. Important IT things you want to think about, how much of your architecture did you just get from someone else? And if the IT fails clean, trust me, it's pretty hard when you mold a piece of code into your architecture that you thought was open source because it's dead and living license. But anyway, so the team sitting there, I basically said, okay, our mission is basically we have 1 year to enter the marketplace with a virtual machine and a complete IDE in order for IBM to have some kind of position. So that's our mission. Now, for a little more detail, basically we built IBM Smalltalk before that. Smalltalk basically has the developer experience that everyone copied. It's not as efficient as Smalltalk. For reasons, this was Smalltalk language is very dynamic. Smalltalk is a language per se. It has to do with the dynamics and it's from its factor. But all the units that essentially an XP mentor or an Agile mentor in the beginning with an underscored Smalltalk word. And website was pick a name, TVD really came from that unit. There, Yama and a good friend who so I'm visiting Switzerland, they wrote good. So we wanted to be able to try and give a Smalltalk experience, which we had integrated version in, much like you would have to get today, but accepted version classes, version methods, classes, and applications, which you say you can call passive. So both source and binary. So you had instant access to any of those. And that's a little more challenging in Java. It was. And then, we need to have a virtual machine. Well, fortunately, we have a Smalltalk virtual machine. So we built an IDE. The first IDE, we're just going to take Smalltalk and modify. We got the year to build it. This whole thing together. But we want to try and have user interfaces that be more modern. So that's the story that's been like the first year, and then basically changing the good story. Basically, because we implemented the IDE in Smalltalk, Sun refused to give us the coffee cup of Java 1. He said, no. Unless it's all written in Java, it's not worthy of the Java. Even though we run everything in Java, it all runs the test we call them. By the way, Sun never actually told us. They would just dump the code to us. We had to dip it to find out the difference between Java 1 and Java 2. With no collaboration. A month before the release of Java 1, on the release spec, they told us there would be no form, no lexical closures. At Java 1, they were telling their biggest part. So this created a lot of disturbance in our team, plus we didn't have a coffee cup, lots of pressure. So that said, okay, what we need now is a project which will take on. And so Eclipse will be the thing that blocks the sun. The other piece is called the ultraviolet magic, or Sunburn. The virtual machine that runs Smalltalk, Basic, every other language that you want, not C, C++, as well as Java, so that we can take the other people with us, because one of the things that happened with Java is it killed off all the people that had good products in other languages. The Sun made sure that they and I was so terrible that we couldn't build any reasonable binding to even a C product. So you see the strategy. And then to make this work, because we've had lots of friends in Smalltalk all over the world, especially in universities, we basically used the C program to make sure that they were adopted of Eclipse. We got them writing all of this wonderful and got off of it. So we had a community. But the vision really just was that was it. But that was enough for 15 people in 15 locations around the world to actually start building. Now, did it work out? We built both of them late in time. But we didn't have time to think about. In Ottawa, where I live, that was we did Smalltalk. We wanted to have the whole IP encrypted. Eric had this wonderful plug-in architecture with all these great APIs, and that was his team. So we said, use only code if you're doing it. Eric was also at the team. With the UI team, were absolutely convinced that no one could compete with Sun and Eclipse Slate. They had to use AWC or Slate. Steve Northover, who worked for me, did all the graphics and UI work. So Smalltalk came to me and said, Dave, I can't do this. This stuff really sucks. AWC sucks. And Swing, stinks. So I said, hey, Steve, I'll transfer you to the embedded system for this embedded UI. Need to use essentially bitlet, things like that. They can't use a big thing. Eric called me. You can't do that. I'm just real. And I've already done it. But was only 6 or 7 months later, Eric was teaching in Munich. And he announced, we got this wonderful thing called SWP, the standard widget toolkit, really speed widget. That's where the S comes from. And we built that with the experience we had in Smalltalk, but improved upon it because we had a bad design. As you always do. If you don't have by the time you finish something, you don't hate the code base, then there's something wrong. You have to burn it for your mind. So it's a long story, but those stories were really enough for 120 days in 50 locations. They could carry the essence in their head. They could argue with people what they were doing. Okay. And the other thing we did is we had a marketing piece that we're not going to be Sun out of the box. We're behind 2 or 3 years. So what we're going to do is we're going to make semantic disappear. semantics was an early player in Java. Then we're going to make Visual Studio disappear because we know that the sun is. And then we're going to basically get Rational and these other tool people to switch to our platform, which will really irritate some, because once they start using SWC and all the use, they're never going to switch up. So we gave them a commercial story and said, don't worry about sun. Take this one out, take this one out, take this one out, and then you're facing sun. It's a very common strategy. And this may not sound like architecture, but it really is, because what you're communicating in the story is the architecture. Right. So I think now we're talking about what can we use in the architecture to sort of help. One of the things we can use is by basically using architectural styles which reduce the gap. Because there are some architectural patterns where there's a one-to-one correspondence, a very close one-to-one correspondence with code. Now, one of the ones here is simply data flow and pipelines, hub sub, and event sourcing, are very natural patterns which are quite easy to implement, and the models and the code are essentially the same. So, right, you might have to hard to come up with some code and things like that. Another one is to use functional patterns. People will finally figure, the design patterns, right? Design patterns only exist because the terrible programming language, C++, and so on that they're in, basically don't have reasonable, they're not very good. Right? They can MapReduce is embedded in HDL and Lisp and used by Google for their scaling. All these patterns exist in reasonable functional programming. Now many of them are coming back in. But the problem is the Java virtual machine really never understood how to implement these stuff. So the classic problem you see is that they said, oh, well, put the lambdas in, and so we can do filters and maps. But the patterns that the bytecodes that get generated are not what Hotspot knows how to do. Hotspot's a bet with the devil, right? And basically assumes you see these patterns in the JIT. But when you put these other things in there, there's something in between. It's function code. So the result is that the lambdas ran slower than if you implemented them in Java yourself. But 2 releases later, they fix that. The lambdas today are indeed. It really complicated the problem. Something that's also very simple. I mentioned this yesterday. I graduated. Fortunately, there was only like 5 books in computer science, and computer engineering when I graduated. So I didn't have to be very smart to understand a lot about it. I really feel bad today because there's thousands of books, most of them crap, and more. So I really feel badly about that. So people said, how do you know so much? I said, well, the answer is it was all written down before, and we had a few really great computer scientists, engineers, and so on. So something that's very dear and near to my heart, and I always say, where in the architecture are we leveraging these things? So this is 2 things, table driven. There are lots of different kinds of tables. I'll just pick my 3 most common ones. Decision tables, state machines, which everyone should know, maybe decision tables. And the other ones are spreadsheets, which are great. You can describe almost all business applications, many process control applications. The substantial parts of the system can be described in terms of tables. And guess what? You can turn those tables into data, and you can write a very small interpreter which runs blazingly fast written in C or whatever you want, and you can port it from inside a process controller to onto an IBM mainframe without changing the code. And you've got hot deployment. You just have to change it. Oh, what do you mean jar? Forget the jar. You have to put it in a jar and then into a container and then go through this whole new. Just change the data. Why is such an old trick not being used more? And again, what it does is it fills the tail. I've seen people who basically write story cards for each of these rules, for each of the cells in the spreadsheet. Here's a story card. And so you have all that you burn out the poor product owner. And again, then if you're really retired, you I shouldn't use that site. That's an old word, and it's not it's really dumb that then code this thing that you've written, you write a cucumber test for it. You have two fragile pieces of code, a piece of Java code, because the cell's going to change next week. There's going to be a new request. I can't think how many times I've seen this happening for real. It's wads and wads of Java code that basically implements the spreadsheet. So if you keep the architecture, and something else is I work with a lot of OO engineers who basically don't want to know, and databases, don't want to, there's something called entity relationship diagram. Now, the only important thing of these diagrams is that some of the relationships are many to many. OO languages, no languages except NIM, actually have many relationships as a first-class concept in language. So everybody who tries it, I want to go a whole repository. He said, oh, you meant those things, you something you were wrong. Maybe that was another measure. And it's very straightforward to take these. So now you can generate any kind of schema you want. You can go to graph schema, you can go to a relational schema. It's a mechanical transformation, but you have to preserve the many relationships. What happens is people go, I don't want another join in my code for good reason. But they lose the attraction. So there are some old things that are useful to teach people, particularly if they're working well with data. And as soon as you start talking about doing conceptual models like you are with AI, concept graphs, and in general, you're much better working at this level than you are using a raw. The great thing about raw graph databases is you can do anything. The bad news is you can do anything. And you can't navigate them easily. It's very different. Versus these, you can navigate them anyway. So where we can, we like to make the code the same. These are words in code. Yep. Okay. Thank you. Thank you. I'll speed up. Basically, I think you all know about these things. You want to version your APIs and agents. We actually put APIs into the code so you can actually generate the API too. Because the only thing we know we can trust is using the source code in the repository. So even if the language doesn't have fancy API definitions, we basically just have annotated comments or attributes, whatever, to do that. So we can actually generate the diagram from the code. They're not pretty, it's not wonderful, but it does it. Obviously, infrastructure is code. This one I like. This one is bigger. Hopefully, you can start to that these days. Architecture strategy. Bloomy is a really nice one by a Microsoft employee and basically Amazon certified. But it's right. Terraform is possible. So, but this is still a lot of stuff, and it's really hard to understand. Particularly, I mean, it's easy when you say, I'll have a router and do other processes, but then you describe a real system with all the flows, especially asynchronous and dynamic, very difficult. Contract-driven development. My favorite tool right now is something called Spetmatic, near SJane, but this is done in India and this is done in Australia. But no one should get by without doing serious contract driven development. Basically, the contract for both sides, the contract to generate the test, or report the test failures, and by increasing these things in property, really does do property-based testing. One, it must all be stuff in PVD. Looked it up. Comes from functional programming, but there's a property-based test framework for every programming language out there. Property-based testing uses the cheap version is fuzz testing. So it uses random, but property-based testing actually uses the properties, essentially of the types of the thing, and generate. But the big thing, randomized testing is a great idea. The problem is when you give it a million randomized records, it blows up. You have to decide which ones are false positive and which ones are put. What quick check does is it finds the minimum sequence of failing tests. So it takes all these failing tests, crunches them down, and says, this operation, this operation, this operation. So it's been used to test things up to 99% level. And that's something that's going to make you feel a lot much more confident about yourself. So I talked about data. People often don't. You do the code, they do the data. Unless it's Mongo, we can throw it in and do the data. That's because you don't ever care about any of that experience. Put it in the blob so nobody can get at it except for the parser to slow what it is. There will not be no SQL database which makes no sense. You can't have things sufficiently queryable. It's just too efficient. So we want to annotate the code artifact. I mentioned pseudocode already. We want to have, this is Mike Familiar's term, architecture design record. So again, this is just something that goes into the repo, ideally associated with the code, but maybe have to associate with 2 or 3 code points. So you may say ADR and inspect these things. It's obviously testable. Notes from code design reviews, very important. Bad bugs bite you more than once. So what you want to do is learn where there's a problem source. And after you see these annotations building up, I'm not a big fan of rewriting, but I think the only solution for some modules is you need to cut it out. And it's like, I'm thinking, what are you doing? We're putting the lines matches. It's never going to be happening again. Boom. Happens for a show. The only thing hard in software for large systems actually systems. That is the hell of large scale software. The dependencies on people, have in their head, but dependencies in the architecture. For some reason, again, we have this tool now, which is taken. This is a tool from manufacturing. Of engineering, where they plan building planes and so on, so they're tracking the dependencies. And they actually use it as a design tool, so they can see where the dependencies are as they're building things up. They've got to schedule them, they have to know about all this. But sometime a few years ago, investor at MIT started doing it, and a bunch of companies, Lattice and so on, started giving you kind of reverse engineering tools that will let you extract these things. Should be using these designers and know they can things. We can see our coupling and connections going on. We can also use it as a test version. So we can test the dependency that we can light it up. But for some reason, it's just one of those stupid diagrams. Architects sometimes. So in order to really do this, we need to continuously refactor our architecture as well as our code. How can you do that? So here's some techniques. First, put the architecture defect issue in there. When it's a bug in the architecture, put it in your Jira or whatever. Hopefully you have a better tool than that. But just log it, put it near the code that's problematic with the APIs associated with it. Have the ADRs that are changed in the movement. So they will find out. You know, basically part of the build, you can get a list of what's happened in this release. It's amazing. What an idea. Could just be printed out every time, every build. What's important is change this time. We want to be able to tell the customers where we've made big changes. Well, we always tell them that the second change is we don't tell them we made an important architectural change. It's not that we've got a new knob and our new on. What about acceptance tests for models? Models typically have relationships. You can often identify those relationships in the code. May not be perfect, but if the model hasn't changed and the code has, there's a problem. Or if the model has changed and the code hasn't, there's a problem. They're not perfect, but they're at least signals that people can look for in terms of the architecture is being separated from the code. And the big one for me is two things now, fitness functions, which I think that's the best part of evolutionary architecture. Evolutionary Architecture is a wonderful book. The problem is that Jeff and Rebecca and the other name, I think, this basically wasn't the bank. Yeah, that's when they're on your team, because they've got all this knowledge, they don't, it's not about the team seeing an emerging architecture. What the team sees is something, and then a smart person or a distinct engineer, someone who's got lots of experience, recognizes it as this. And they say, oh, right, that would be better as event source. But you have to know what event sourcing is. You're not going to have that pop out of the, so that's my only criticism is basically, this is how Rebecca and Jeff and Pat, how they work and how they live. And that shows the benefit of having someone with a lot of experience, reviewing and looking at things, because they can help you say, look, you see what's happening here. This is a place where you could do this or this or change your architecture. So the other thing is basically ellipses. I don't believe in non-functional requirements. If there's a requirement, there should be an acceptance step. Or what it is, performance, UI response, fault tolerance, failure rate, whatever it is. If you can't test it every build, then you're failing. These often capture important things about the architecture. These things you're saying, we're expecting our architecture to give us 5 nines, 3 nines, or whatever it is. So let me just finish where I think this is going. I mean, the reality is we're getting into very dynamic architectures, asynchronous microservices, where everything talks to everything else. Everybody rewrites. Nobody believes in using a good library or even for crypto. They have to write their own for their team. That's a good idea. So again, people get a bit jealous about it. We're not going to be dependent on anywhere. You use the compiler. Oh, direct your own. But the big thing here is when they're very dynamic, very hard. It's hard to draw even if you're doing it. Drawing the dependencies is hopeless. You have to use the tool. But what you've seen is particularly created by, when you work with asynchronous systems, the only thing you can do is look at trace. So this is now called observability. And basically it's software analytics. And we've certainly done some of this. The code of the crime scene is another example of this, where you actually write queries. The same thing you do for cyber analytics, by the way, so it's a bad thing. So it's very important now to write queries over large data and basically turn that into pictures of the architecture. So this is the way it's going, and then you're going to be able to interview the results of this analytic data set. You'll be able to interview it with something like an LLM. So that's going to allow people to actually interview and talk to their architecture. So the more annotations and information's in there, the more the architecture will pick up. So, thank you for putting that. So basically, like everything else, if your culture sucks, your organization and your software will look like it. Thank you, Fred. No, Conway. If you don't have a healthy architecture, you won't have a healthy code base. So trying to keep these together and coming up with simple tricks like even ADR made a big difference for people that have done it. Oh, we did actually change things at this point. Or we said we were going to, but nobody ever closed this API. Thank you very much for your time.